Welcome back. This is SLO 9 Part 2. We are still solving application problems involving periodic data. Let's go straight into an example. A sailboat is rocking up and down in the ocean with its displacement from the ocean floor modeled with the equation y equals 0.5 sine 5 pi t plus pi over 2 plus 30. Y is in feet and t is in minutes. We're asked to find the frequency, find the maximum displacement of the sailboat from the ocean floor, and we're asked to graph the equation. Okay, so we have an A value of 0.5, meaning the amplitude is 0.5 feet. The sailboat will go up 0.5 feet and down 0.5 feet. We have a period of 2 pi over v. This is 2 pi over 5 pi, which is really just 2 over 5, or 0.4 minutes. The first thing we're asked to find is the frequency. This is related to the period in the way that it's b over 2 pi instead of 2 pi over b. So we have a b of 5 pi, which we will divide by 2 pi, and get 5 over 2 cycles per minute, or 2.5 cycles per minute. So next, we're asked to find the maximum displacement of the sailboat from the ocean floor. Maximum displacement is equal to the amplitude, so it's just 0.5 feet in this case. Some more information, just the vertical shift is d, and this is 30 feet upward. The horizontal shift is pi over 2 to the left. So typically in a sine periodic function, we will start at the midline from the origin and go to pi over 2, as I explained in the previous video, for the maximum. But in this case, we are shifting to the left by pi over 2, meaning we're starting at a maximum. So really, this could also be written as a cosine graph if you just remove the phase shift of pi over 2 to the left. So let's graph this equation. So we again have the equation 0.5 sine 5 pi t plus pi over 2 plus 30. So we know this is a sine graph. A sine graph typically starts at the origin and its midline and goes to a maximum at pi over 2. However, we have moved pi over 2 units to the left because of that phase shift, meaning we actually start at a maximum. Now recall the amplitude is 0.5 feet. So we will go from the midline at 30 to 30.5 and the midline at 30 down to 29.5 feet. And we just have all of these points that we can find. Recall that the period is 0.4 minutes, and this can be found here, where it goes from maximum to maximum. So one full cycle is completed in 0.4 minutes, making that the period. Again, the frequency is 5 over 2 cycles per minute, or 2.5. So we actually have a minute here between 0.8 and 1.2, halfway between that, that's 1 minute. And you can actually see that there have been 2.5 cycles completed, because if we think about this is 1 cycle, 2 cycles, and half a cycle here. So knowing this, we can graph all these points here. We know again that we start at a maximum, so then based on the amplitude and knowing that this is a sine function, we can graph these points here. When we actually connect these points, it looks like this. Remember that x is in minutes, y is in feet. And yes, that's pretty much it for this video. Thank you for watching. Goodbye.